In this assignment, I, as well as my classmate Henry, were tasked with making a decibel monitoring system for a workshop in our school. My part of this assignment was coding the sensors themselves and allowing them to upload to the database in a way that could be analyzed easily. Luckily, we did have code available that connected the Arduino chips to SQL programming, which we used for the database. It does this using various processes, including this one, which initiates the SQL code and tells it which database to send the code to. The second part determines with the data that gets put into the table. It starts with the names of the variables that will be put in, as well as dictating the order that they will be inserted by a column. The second part dictates the values that will be put in. In this example, it was set to 999,999, but in the actual code it is set to the correct variables. Another part of the code that is rather interesting is the code tied to the variable instantDB, such as this code, which primarily aims to reduce the amount of outliers in the data, as most of the data is averaged out, which I'll explain shortly. The way this code reduces outliers is rather simple. If the code detects whether the instantDB or instant decibel value is outside of the maximum or minimum averages, which it shouldn't be, and if it is outside that range, it brings the minimum or maximum to the instant dB value to make the data be more precise. This code is what controls all of the averages. It takes 10 samples every minute and averages them out using the avgx command. Another section I played a major part in was creating the database for the data that the sensors receive to go into. It is a unique column for every value that is sent to the database, from the current sound level in the room to the minimums, maximums, and averages, and even which sensor is sending said data. It can even sort the data into a line graph, which can be analyzed a lot more efficiently than looking at the table row by row. You are also able to select and deselect any variable to be included or excluded from the graph, so you can focus on specific aspects. To talk more about the database and how the data is presented, here is my partner Henry.
And this is what the data looks like on the database. This is the last 400, so 40 minutes of time from the sensor. So it's about 4 times as much data as is shown on the monitor system.
Due to our efforts, this code is able to run automatically and independently, so long as it has power. It is able to document the data that the decibel sensor receives and transmit it to the database. One major flaw in this project is that it types the SQL code directly into the database from an external source, that being the chip. This is a concern because it poses a large security risk to the database, as it means that anyone can access and modify the data if they were able to use the same method the chip does or gain access to the database's IP or login information. The reason this process was implemented was simplicity, as other methods would have taken much longer to code.